Okay, so in this video, we're going to start talking about UVs, the basics of UVs. So if you're a beginner, this is going to give you a little bit of insight on how it works. I like to know information kind of behind the scenes of what's going on to help me understand things a little bit better. So that's what I'm going to share with you in this video. And then in future videos, we're going to go back into Unreal and we're going to start dealing with more stuff. So you're going to try and understand what's going on behind this idea of UVs, this coordinate system that we're dealing with. So if we look at this image here, what we have is a two-dimensional map, which has this x-axis and y-axis, and that information is then applied to a three-dimensional shape. It's wrapped around a surface. The concept here is very similar to what we do in UVs, but the map system is actually the origin of our coordinate system in 3D. So x, y is representing, sort of the forwards, backwards, side to side. And Z was used later to represent height or depth information. And eventually, in this wonderful three-dimensional world that we were creating in these computers, we've decided, hey, other than just one color of an object or one color per individual face, how about if we start applying textures to the surface, these images, pixels. So we needed another coordinate system. And the obvious option for them at the time was just to go to the next three letters of the alphabet. So U, V, and W. And U and V have stood the test of time. They're still utilized and mentioned a lot because they deal with just the surface information. But there was a value for W, which was depth information, and that usually would apply to three-dimensional textures, 3D fractals and stuff like that, procedural texturing. So U and V, unfortunately, is often mistaken for UV light, and UV really doesn't stand for anything. So UV is just a coordinate system, it's just the next letters. When we move to the 3D software, we'll see UV is often represented like this. There'll often be some kind of grid that's there, and we'll have a 0 to 1 value in V and 0 to 1 in U. And so this grid system uses decimal places between those values because there isn't any whole values between 0 and 1. It uses decimal places, and it depends on the granularity of that. So 0.1, 0.01, 0.001, 0.0000001 to determine that, and that makes this resolution independent. It can go on and on and on with these decimal places on into infinity if it really wanted to. And that determines sort of the maximum resolution of texture that you could utilize in that particular software. So if it only goes, to a certain amount of granularity, then you have to be aware of that. So if it only went, one place, well, 0.1, you're dealing with basically 10 values, right? You can only have 10 pixels in here because you can only do that. And that wouldn't be very cool. So anyways, a lot of software will allow you to do things like, 13K textures. It becomes more of a memory limitation than, say, the limitation of the software. So when we go to Unreal, often we have black representing 0, and a gradient will be applied over top of that. And so for the U value, we're going from black to a maximum value, usually in the red channel. So you could see this as a grayscale image where white would be the value of 1, black would be the value of 0, then you'd have all those decimal places in between. This is not actually a texture. Again, this is just math being represented here. So it's, again, resolution independent. If you were to use that particular channel in Unreal as a texture, you could zoom in and zoom in and zoom in, and you'd never see individual pixels, except that you can because it has a maximum resolution that it allows for. We add to that, and we go with the green channel. In Unreal, it's a little bit backwards, a little bit. It seems to be flipped. And so we have the brighter value at the bottom, the darker value at the top, but essentially it serves the same function. combine them together, and we get this image. So if you ever popped open one of the nodes inside of Unreal, just by clicking the little triangle in the corner, you might have seen an image like this. And what's happening here is this information is just a way of translating the texture. It takes the texture information and it says, okay, here's 0, 0. I'm going to take that and I'm going to plop it here. And then this is 1 in V and 0 in U, so it'd be 0, 1. And we go over here and there's that bit of the image. So in this particular case, this is like a process that people use in some art schools to help people learn how to draw. It's just a simple translation. But in terms of the software, it's pixel by pixel. It's going and reading individual pixels from the texture using that coordinate system. What we should understand with this is that even though it goes from a 0 to 1 value, it's actually possible to repeat that. So as it goes beyond that 1 value from 1 to 2, or 1 to 2 in V, it will continue to produce more and more of that same image, just continues to repeat on into infinity. There would be one here as well, where it would be from 1 to 2 and 1 to 2 in these coordinates. Also in the negative direction, going to from -1 to 0 in both these axes, it also repeats there as well. So you can go to negative axes. So over here in Maya, we're going to look at the physical information that's going to be applied to this. So if I take this mesh and I grab one of its corners and I pull it out, you notice it's only pulling on one portion of the image. There's no edge going through here. This is an actual quad, and yet we're getting this interesting kind of response. It goes even worse than that in that you can start messing with these, and sometimes, it's probably not going to do it for me right now, but sometimes you may see this line kind of pop. And what it will do is actually this. It's choosing arbitrarily where to split this into two triangles, because that's what the computer sees. The computer sees triangles. It doesn't see a quad quite so much. It's trying to place this in triangular spaces. So if I split this like this, both sides now are moving. Of course, they're getting distorted, but that's what it is. And yet, if I grab this side, once again, I'm stuck with that same problem. So the idea here, delete that, back to the other one, is that we have to deal with this in UV space. So I've got my UVs over here, and there's that 0 to 1, and then 1 to 2, 2 to 3, and so on and so forth. We can see it in the grid system. The texture is not repeating here because it's not set up to show you that at the moment. But if I take this image, this representation of these UVs, I'll grab a UV, and I'll pull it out to match the same shape as what we see in the 3D viewport. That distortion goes away. It's no longer distorted in that way. So as long as the shape of the polygon in the UV space is the same as the polygon in the 3D space, then your textures will remain undistorted. However, you can also minimize distortion by adding geometry. If I take this, and I'm just going to go ahead and add some edge loops to this, I'll just match the current grid pattern that's here because that's the most convenient. And that distortion goes away, at least for the moment. If I increase the resolution of this texture, so I'm just going to go into the attributes over here. We've got this place 2D texture node. I'm just going to go ahead and increase this, say, to 8. And we're getting closer here. You're going to notice that there's a little bit of distortion going on yet again. So the resolution will have an impact on how distorted or not distorted this is, even though the UV shape doesn't match the three-dimensional shape. So the texture itself will distort, but those weird skewings between them will depend on the resolution of your texture and the resolution of your mesh. Now, of course, it's not always ideal for you to have to increase the resolution of the mesh. The more polygons you add, the more dense the mesh, the slower things can calculate, the more memory it can require, etc., etc., etc. So you want to be cautious with how much of that you add. Now, I'm going to go ahead and subdivide this again. That. And this mesh, see, it's still connected, it's still part of that. Then UV space, I'm going to grab this edge, shift right click, and we're going to go cut that face, pull off. And now you can see that I'm able to move this around to get to another section. And as I move it off into, say, this other region here, you'll see that it's just simply a repeat of that same texture. Now, of course, when they don't align, we often will end up seeing physical seams. And again, even though I've cut this in UV space, it hasn't cut it inside of here. UVs and their information are independent from the surface. Again, they're another coordinate system. The best real-world analogy that I can offer for that is if you were a painter and I asked you to go into a building and paint my name on my desk. I would tell you, go to the 3rd floor, go 5 rows down, and then 2 computers in, and that would be your XYZ coordinates to find my desk. The 3D information in the real world. But you need other information. You need to know how big you want to put my name on my desk. How big should you paint it? Where should you paint it? What orientation should it be? That's your UV coordinates. And so they're a completely separate set of information, and they can have their own rules. I can also share UV space. I can share the same information so I can repeat portions of the image on that mesh multiple times. So keep in mind that your UVs are not related directly to your three-dimensional shape. You can do anything you want to them. You can distort them, you can break them, and you can even scale them. You can change the size of them. Now, if you do something like this is something you want to be careful of, because depending on how your software is processing the information, you can end up with really crisp information, so it would be nice and crisp texture, and over here it may look pixelated or blurry. And this will only enhance things like seams, even if you're using something like a 3D painting software, say like Substance Painter, in order to paint across those seams, to try and hide them. Keeping the size relationship to the UVs here, as well as the size relationship in the real world so they match, will ensure that even if you have seams, you can quickly and easily hide them where people won't notice them. So these are the basic rules of UVs inside of UV Editor. Some additional things that we'll be playing with when we move back to Unreal is how we can manipulate how the software is manipulating the image itself. What is it doing to it? So that that representation that we see here is utilized to place the pixels on the surface. This is how the software is reading the image. It reads at 0, 0 to pick up that pixel, and at 0, 1 pick up this pixel, and 1, 1, and 1, 0, etc. To grab those different pieces of information. So that's what this is here in Maya, where I'm repeating the texture here by doing things like typing in numbers, and I can do one or the other, and we can do that. You can also offset the image, pushing it around. just going to reset this back to its original lovely square shape. So you can see some of this other stuff. So I can rotate it, and if I remove this offset, negative 5.5 rather, offset, you see that rotation has specific centers that it rotates from. I can even, just holding down control here and dragging, I can distort it, and this is all happening in that same way, where it's changing how it processes the texture before applying it to the mesh. So the UVs determine what portion of the final image goes onto the mesh, just kind of like that grid system here, where we pick individual sections of it and we apply that to the mesh. And we also have the way that it processes the information itself. So it goes through two layers of processing. That's basically how the UVs are working. The only thing that is a little bit different here, where UVs kind of break, is dealing with the idea of projections. So if you create a projection, you may be using something like world space to apply it. And 3D textures, which is that UVW again, basically where the mesh intersects the volume. So if you were to imagine something like a huge chunk of Swiss cheese and you want to cut out a sphere from the inside, the sphere would be your shape, and that portion of the cheese which you're taking would be your texture, what you see on the surface. So where the bubbles appear, where the cheese itself appears, would be that three-dimensional texture. You're just cutting a chunk. Or if you're familiar with the idea of, say, an MRI, MRIs use that kind of idea of individual slices of a texture to represent a whole. So projections will process this information a bit differently. It'll kind of ignore this UV space information because now it's using, say, world coordinates to apply this to your surface. And we'll look at that in perhaps the next video.